Hey everyone, Mr. Scullin here, back at it, Lesson 8, Unit 10. Today we're going to be continuing our discussion on rational expressions, and we're going to focus today on something we call complex fractions. Complex basically means this: a fraction within a fraction. Okay? And whenever we have a fraction within a fraction, we want to make it into one fraction. That's our goal. So let's jump right into it. You can see this problem right here. We have a fraction within a fraction, and I know you're thinking, well, wait a minute, you got a fraction on the top but not on the bottom. Well, you can make this a fraction by putting a 1 underneath it. As we go through this lesson, we're going to get progressively more difficult, so this is pretty basic. Now, the first thing that a lot of students will do, and a lot of teachers will teach, is to rewrite this problem and think of it in a way that you have seen before, that have been exposed to before. In other words, this. Really what this is saying, right, is 1 over x divided by y. And so what have we done? What did we do in lesson 6, right? When we had fractions where we're dividing, we would take the second one, keep the first one the same, we would change it to its time sign, and we would flip or multiply by the reciprocal of the second. Well, if you do that, you just get 1 over xy, and that would be our answer, right? Because we're always multiplying the top times the top and the bottom times the bottom. Now, we're always going to state restrictions, okay? And so in this case, when we talk about restrictions, I'm going to make a very point here, an important point. With restrictions, don't just look at the answer for possible restrictions. That's a good place to start. But what you really need to do for restrictions is at any point in time within the problem. Okay? I didn't mention that in lesson 6, I believe, or 7, but I'm making a point of it in 8. Restrictions aren't just, a lot of people will look just here, but you have to look at any point in time in the problem to see if there's any other restrictions. In this case, the restrictions for this problem, x can't be 0, y can't be 0, because if x or y were 0, we'd have a 0 in the denominator, no good. All right? So, let's move on to the next question. Now, we have a situation here where we have 3 divided by this. What you're going to have to do in some of these situations is first, you're going to have to get a common denominator within either the numerator or the denominator. For example, here, 1 minus, I can't do that, right? Because I got to get a common denominator with the 2 y's before I can put this together. I need to push this together with subtraction. In order to do that, I need to get a common denominator of 2y, right? So really this problem gets written like this: 2y over 2y minus 1 over 2y. Now that I have a common denominator on the bottom, I can rewrite the problem as 3 over 2y minus 1 over 2y. So now I have a fraction within a fraction. Now, instead of doing what I did on the first problem, this is what I like to do. I like to just multiply by the reciprocal on the top and the bottom, which is essentially what you're doing anyways. So these reduce out on the bottom, right? And on the top now you basically have 3 over 1. I'm just making 3 a fraction. 3 over 1 times 2y over 2y minus 1. And so what does that give me? That gives me 6y over 1 times 2y minus 1 is just 2y minus 1. That is your answer. No, you cannot go 6 divided by 2 and make that a 3. You cannot do that. People are going to continue to do that. The reason you can is because it's 2y minus 1. It's connected with a subtraction or an addition. So you can't cross out these y's. You can't cross out the 6 over 2 and make it 3 because you have this minus 1 connected to the 2y. Now, in terms of restrictions, what can't y be? Well, you can always set the denominator equal to 0 and see what that would be, which would be 1 basically equaling 2y, so y would equal 1/2. So y cannot be 1/2. is there anything else throughout any point in time in the problem where we would have a restriction other than what we have here of 1/2? And the answer is yes. If you look at this real closely here in terms of restrictions, y can't also be 0 because 2 times 0 would be 0, and 1 divided by 0 would make this problem undefined. So that's what I was talking about back on slide 1, is always be careful of the restrictions. Look at your answer, that's great, but always look back in any point in time in the problem to see if there is a spot where you could have a possible restriction. Number 3, yikes. Okay, so what do we need to do first here? Well, the first thing we need to do is we need to get common denominators in both the top, so the numerator, and then the denominator itself. So we need to, I'm going to focus on the top part. So I'm going to multiply this by x, and this by x, and then this side by y, and this side by y to get my common denominator of yx. It would look like this: 5y over xy minus 2x over xy. Okay? And then divided by, and I'm going to do the same thing down here. This needs to be multiplied by x, this needs to be multiplied by y and by y. So I get negative 4y over xy minus 6x over xy. And then I got to simplify, right? Push those together because it's subtraction now. Because I have a common denominator, I can go 5y minus 2x over xy over negative 4y minus 6x over xy. Okay? Then, now that I have a fraction within a fraction, so all that work just to get to this point in time, now I can multiply by the reciprocal of the denominator. So, because it's multiplication, the whole point of this is to get rid of the fraction within a fraction. That denominator is completely gone. So now our focus is on just simplifying that. Okay. What you'll notice is these, because it's multiplication, these end up crossing out with each other, and you're just left with 5y minus 2x over negative 4y minus 6x. Okay. Now some students will factor out a 2 or a negative 2 in the bottom. You could do that to leave it in factored form, but I would probably just leave my answer just like that. Okay. Restrictions. If you see any restrictions here, but especially in the beginning of the problem, you know, x can't be 0 and y can't be 0 because of the very beginning. You'd have 2 divided by 0, which would make it undefined. 0 here would make it undefined throughout the process of the problem, and so those are our restrictions for number 3. All right, so we're on the last question, number 4 here, probably the toughest one that you're going to see on the notes for sure today, and we'll just jump right into it. So again, what we want to do first is simplify the numerator by finding a common denominator, simplify the denominator, getting a common denominator, and then we want to do some basic division. So let's jump right into it. I look at my denominators here. I know that I can times this by x, top and bottom, and I can times this one by x plus 1 because that's what it's missing. And then if I go to simplify this, you can leave this in factored form, but I would suggest when you start to do complex fractions like this, you actually want to distribute this x plus 1 with the x minus 2 and get a trinomial, a quadratic. So that would become x squared. You can just FOIL it. Some of you can do it in your head. That's going to be minus x minus 2. And then this is a negative symbol, or a minus, so it's minus 2x, like that. So that simplifies into x squared minus 3x minus 2 on the top of this numerator. The denominator is the common denominator of x times x plus 1. And then I'll use blue pen to do the bottom. So I'm going to times that by x minus 1, x minus 1, x plus 1 over here, and x plus 1 to get that common denominator. So over here I'm going to get 3x plus 3, so I'm distributing this 3 to the x and the 1. And then this is like a negative 1. I could make that a plus sign, make that a negative, and distribute negative 1 to the x, which would make it negative x, and then positive 1. A lot of students are going to make that mistake. When you have a subtraction sign here, you have to take that. I always put the negative here and add it, and then I'm going to get 2x actually, plus 4 on the top over x plus 1 and x minus 1. So I get something like this when I have simplified the numerator and the denominator. So this is what my focus is. It's division, so I'm going to multiply by the reciprocal, top and bottom. Okay. The whole point of doing that is so that you get rid of a fraction within a fraction, and now our focus is just here, and now we're looking to simplify that. Multiplication in between everything so the x plus 1s can cross out. I would look to factor this back out to see if it factors with anything on the bottom, but you can't factor x squared minus 3x minus 2, so what we have left on top is x squared minus 3x minus 2 and x minus 1. I would leave it like that. On the bottom you have x times 2x plus 4. In some textbooks or answer keys or whatever resource you're working with, you may see some people factor a 2 out of this, and so the denominator, you could have an answer that would look like this. And you could see some people actually distribute the top through and simplify that, but you could pull a 2 out and have 2x, this 2 would come out, and you'd be left with x plus 2. So you could have something like that as well. I'm off the paper, there we go. This answer works, this answer works. In terms of restrictions, we're always looking at restrictions, right? What can't x be? Well, x can't be 0. I'm looking at my answer first. X can't be 0. X can't be negative 2. And then I look within the problem. X can't be negative 1. Because if I made that a negative 1, that would make it 0. I can't make this a negative 1 or a positive 1, because that wouldn't work as well. Okay? So those are your restrictions here. You can have either answer. All right? As always, look forward to seeing you in class. If you have any questions, let me know.